Hello, everyone. I'm honored and happy to join the ninth World Congress of Teledermatology, Imaging, and Artificial Intelligence for Skin Diseases. I thank organizers for inviting me for this prestigious meeting. I will be speaking on deep learning skin disease classifiers, current status, and future prospects. I have no conflict of interest. I have been involved in development of an image diagnostic app. However, I have no financial involvement in it. So as conceptualized by Eric Topol, the old dermatology is creatively destroyed into new dermatology because of superconvergence of newer information technology, which include artificial intelligence, mobile connectivity, internet, computing power and metadata, social networking, genomics, and imaging. On the other hand, there is a surge in the demand of dermatological care across the world, and is shown the popularity trend through the internet search related to skin diseases. There is a constant increase in the demand of dermatology care, and some of the countries have greater demand as compared to other countries. So here you can see that some France, Monaco, Japan, among the top countries for dermatology related searches on the internet. The AI pattern recognition can improve the dermatological demand in the healthcare. And the other specialties which are going to be impacted by artificial intelligence development are radiology, pathology, retinal imaging, and endoscopic diagnosis. Most of the current studies and applications are cancer-centric because skin cancer, particularly melanoma detection, is so important. Because if melanoma is detected in the early stage, the mortality, only 10% of the patients die. And if melanoma is detected at the late stage, only 10% of the patients survive. Therefore, rightly so, the initial focus of artificial intelligence application in dermatology is on detection of skin cancers. On the other hand, teledermatology may be the first field to embrace artificial intelligence because in teledermatology cases, as the dermatologist is sitting at a distant place in the virtual world, providing consultation, here the accuracy of deep learning classifier matches well with dermatologists as shown by Liu et al. In a study published in Nature Medicine in 2020. The accuracy of DL classifier was 0.67, while that of dermatologist was 0.63, which was much higher than the primary care physician's accuracy of 0.45 for 26 skin conditions. AI may be integrated into the smartphone applications to photograph skin lesions, collect relevant clinical information, and generate a referral if appropriate or if needed. Many smartphones already support on-device deep learning like Google's TensorFlow Lite and Apple's Core ML. So in that case, the data need not to be shared to the master computer or another machine, and the patient privacy can be maintained. I must caution here that a systematic review found that nine studies that evaluated six algorithms-based smartphone applications, and the diagnostic accuracy of these apps was generally poor, and the authors concluded that currently AI is not mature enough or efficient enough to be implemented in the practice. In addition, there are other issues, and the biggest issue is with the data sets. As reported in JAMA Dermatology in one of the recent issues, there are three challenges in relation to data sets. Number one was sparsity of data set characterization and lack of transparency. Number two was non-standard and unverified disease labels. And number three was inability to fully assess patient diversity used in algorithm development and testing. Most of the reported algorithms do not provide detailed information on the data set which has been used for development of deep learning algorithm. Now, these are some of the applications which are already available in many countries, and most of these, they address only white skin, and most of them are cancer-centric and primarily developed to detect cancer. However, now certain applications are being made available, which can classify individual diseases or which can diagnose individual common diseases. So we also conducted a study on dermatology image-based diagnostic app using machine learning. And this mobile application was actually tested in the clinic setting. So in this study, we used the public database and private database collected by board certified dermatologists. And there were CNN training images of 12,350 and testing images of 3,068, and comparison of model diagnosis against predetermined diagnosis was done. And these 15,418 images were used for training of model to generate smartphone application. Now, this app was then tested by physicians and compared with dermatologist diagnosis in 5,014 patients. Out of these, 932 patients were from primary health center, 383 patients were from urban private practice, and 3,699 patients were from urban tertiary care hospital in a metropolitan city, Delhi. A single image per case was stored and tested on app by a separate blinded physician, and the app offered a single primary diagnosis, and up to a total of 3 diagnostic probabilities were suggested. Diagnosis made by app was compared with the actual diagnosis made by a dermatologist. So the app suggests a diagnosis in this form. It suggests a probability of in the form of percentage, 88%, for example. In this squamous cell carcinoma, probability is 88%. Keratoacanthoma is 9%, and basal cell carcinoma is 2%. So in urban private practice, the top one accuracy was 80.33% as compared to 94.33% top 3 accuracy. In rural setting, 76.55% and 90.51% top 3 accuracy. And in tertiary care, 74.9% top 1 accuracy and 89.22% top 3 accuracy. And overall combined accuracy was 75 for top 1 and 89.62% for top 3 accuracy. The mean top 1 specificity was 99.11%. So in this graph, as you can see here, is it shows the highest diseases with highest accuracy, such as hidradenitis suppurativa, basal cell carcinoma, vitiligo or leukoderma, acne, alopecia, molluscum contagiosum, melasma, thyosis, tinea cruris, corporis, and faciae, squamous cell carcinoma. While certain diseases had lower accuracy, and these are melanocytic nevus, rosacea, fixed drug eruption, candidiasis, and tinea pedis. Now, the length of the dotted line depicts the increase in sensitivity between first and the third predictor of the app, and the size of the icons depicts the number of patients or that disease class. So you can see here that common as the diseases become common, their accuracy by in the diagnosis of the smartphone app improves. So the machine diagnose common dermatological conditions better as compared to those which were uncommon. Now, this shows a confusion matrix of top 1 prediction of clinical data by app. The numbers in each row are normalized to 100, and the actual patient number for each disease class is shown in the parenthesis here. This is a chart which depicts the degree of accuracy with which the machine predicts specific diseases. On the y-axis are actual diagnosis, and x-axis depicts the predicted top 1. So these are the actual and these are the predicted top 1. And a line going diagonally across the chart, which this depict the true positive and show the high accuracy for the most of the diseases, as in this shown in this heat map. So you can see here that some of the poor performance like eczema, which had 54% accuracy. This is again for the same confusion matrix for top 3 prediction, and here you can see that this diagonal line become more prominent, suggesting the improved accuracy. Accuracy of the most of the benign conditions was good, except eczemas were confused with psoriasis, lichen planus, and tinea, and melanocytic nevi were confused with pigmented BCC, and tinea manum and pedis were confused with psoriasis and eczema, and a bullous pemphigoid was confused with lichen planus, eczema, and pyoderma. Performance was there was high top 3 sensitivity for basal cell carcinoma, squamous cell carcinoma, and melanoma. We also conducted an independent study in which we did validation study for artificial intelligence app in biopsy confirmed cases. So there were 19 patients who had skin cancers or pre-cancers, which included melanoma, squamous cell carcinoma, basal cell carcinoma, and Bowen's disease, and 15 types of benign diseases, 109 patients of 15 benign diseases. So 128 patients, single image from each patient was fed to the algorithm. Top 1 sensitivity in this case was 75%, and top 3 sensitivity was 93%. However, for skin cancers, top 1 sensitivity was 84.2% and top 3 sensitivity was 100%, means all skin cancers were detected in top 3 sensitivity, top 3 probabilities suggested by the app. Top 1 specificity was 99.1%. So the performance of app was much better in histopathologically confirmed cases. So this is again the summary. Cancer for cancers, the top 1 sensitivity was 84%. For all diseases, it was 75%. For top 3 sensitivity was 93% and 100% respectively, and top 1 specificity was 99%. So we also conducted a study, image-based study, for basal cell carcinoma, performance of machine and detection of basal cell carcinoma versus non-dermatologist versus dermatologist. So we trained a smartphone application for 40 diseases, including BCC, and 36 dermatologists and 14 non-dermatologists, including nine general physicians and 5 surgeons were included in the study. And we included the histopathologically confirmed images of BCC, 58 in number, and non-BCC, 42 images. And dermatologists and non-dermatologists were not aware of the BCC-centric nature of the study. And we randomized these images in Google form, 100 images, and online survey was done. And here you can see that the app sensitivity was 80.24% in detection of BCC as compared to 45.98% for dermatologists and 10.71% for non-dermatologists. But surgeons had a slightly higher sensitivity as compared to non-surgeon, non-dermatologist. So overall accuracy, here you can see that 84% for app, 65% for dermatologists, 54% for surgeons, and 43% for non-surgeon, non-dermatologists. So this study is important because in daily dermatology, we often receive the patient's image and we have no opportunity to examine the patient in real physical world. So in this case, the artificial intelligence can help in a much better way. This is the area under curve, and here you can see that this line is quite centered in these dots, and most of the dots are under this line, suggesting that the app's performance is much better as compared to physicians and dermatologists. We also performed a literature search and on studies on dermatological disease classification, and we found 3 studies which included multi-disease classification involving 10 or more diseases. And we used a keyword of dermatology and a machine learning or deep learning or neural network or artificial intelligence in January 2020 with no restrictions were set on study type, language, or year of publication. And these studies were based on clinical images alone. And all the previously published work on skin diseases, disease detection using machine learning has focused on in silico algorithmic validation and done on the computer rather than in the hospital by actual physician users. So our study was a first of its kind, which was tested in the real life scenario. So these are the 4 studies, and here you can see that accuracy is very similar among all the studies, with the exception of Han et al., which had 57.3% accuracy. But in remaining studies, it is around 70 and between 70 and 80%. So about future. So automated AI skin diagnosis is ready to be tested in the clinical environment. It has potential to provide diagnostic support and expanded access to care. AI becomes effective in assisting primary care providers with triage through teledermatology, and referrals to the dermatology will be for more complex diagnosis and fewer benign diagnoses. AI may be superb at fast and intuitive pattern recognition, but is still far from attaining human level insight and judgment. Dermatological expertise and clinical correlation will still be needed for fine-grained diagnosis and management decisions or unique cases requiring contextual knowledge. So another issue is the future model should recognize samples that the model is likely to get wrong with, the option to abstain from predicting. So if the disease is out of distribution disease, which is the algorithm is not trained for, then it should refrain from predicting. If the image quality is poor, then also it should refrain from predicting. And in addition, there is another issue is reproducibility or model interpretability, and whether the machine is evaluating the right kind of area in a given image. This can be shown by saliency mapping or a heat map kind of picture, which should be shown in the algorithm or in the app in future models. So in future models, the model report standard should report the standard metrics, which include dataset characteristic, model disease discrimination, model calibration, and model robustness to stress test. And this uniform reporting will provide an opportunity to compare different algorithms of diagnostic algorithms for dermatological diseases. There is a lot of apprehension among dermatologists, and around a quarter of dermatologists, they feel anxious and they feel that AI will affect their practice adversely. And about a third of the patients, they neither agree or disagree to this statement, means they are not sure how AI is going to impact their practice. So dermatologists should invest in deep empathy, and dermatology is dehumanized, running into a business model in many settings. We need to put more emphasis on empathy, presence, and listening, communication, and laying of hands and physical exam. AI is a gift of time. It better work. It gives opportunity for better work-life balance. There should be more focus on cognitive dermatology and procedural dermatology, which obviously AI cannot deliver. So it is not man versus machine, it is man plus machine. AI is there to assist us, help us in delivering better dermatology care. I must acknowledge our collaborators, Sharad, Vikas, and Julie, and I thank you for your attention.